Hello everyone, hope you're doing alright. I have another example to take a look with you with dynamics in 2 dimensions. I've got the example written out here. I push a 15 kilogram toy car. I know that's an awfully massive toy car. That's over 30 pounds, but you know, I needed something that would roll with little friction. And I found a picture of a car that I could put in. I did not draw that. That's actually some clip art that I found on this program, so you know. Alright, so I pushed a 15 kilogram toy car on level ground with 150 newtons at an angle 30 degrees below the horizontal. So that means that I am not pushing this car perfectly horizontal like this. I'm actually pushing the car like that at an angle. And it says to assume no friction. So we want to draw a free body diagram. We want to determine the weight of the car, and remember what that means is just finding what Fg is. Determine how much force I push down on the cart, determine the normal force on the cart, and then determine the acceleration of the cart. So we're going to start with doing a free body diagram because that is really, when you're doing dynamics, one of the most helpful things that you can do with virtually every question. Try to figure out what is happening with the forces, both generally in direction and with size. Alright, so we have this force of me pushing down on it like this at an angle. We have gravity pulling down on the car, and then the car itself is not going to accelerate down into the ground. It's going to accelerate forward, so that means that there has to be a normal force going up. But what I hope you can recognize here, that the normal force is not going to be the same size as Fg right now. Fg is a certain value, but I am also pushing down somewhat on this car. And so I have to have a normal force that is going to resist both this and me pushing down. So this normal force that I'm going to draw is going to be bigger than gravity. Alright, so I'm going to label these now. We know that, first of all, this one is the force of gravity, Fg. We're going to call this one Fn. That's the normal force. And then the force that I am pushing, I'm going to call that Fa. And the A stands for applied. I am applying a force. Alright, so that would really be A for the question. Draw a free body diagram. But I'm going to add one more kind of piece here. I can recognize that this force here is on an angle. And so what I'm going to do is I'm going to draw in the components of this angle. So really what's happening is that I am somewhat, I'm going to try that again. I am pushing somewhat to the right and somewhat down. And this angle right in here is 30 degrees because the question says 30 degrees below the horizontal. This is horizontal, and so I go 30 degrees below that. So I know that this angle in here is 30 degrees. And in fact, I am going to put that in so that it's a little more obvious. 30 degrees. There we go. So that's in there. And what I'm going to do now is I am also going to label this force going to the right, and I'm going to label this force going down. And really, these are just components of this applied force. So I'm going to call this one FAX because it's going in the x direction. We typically think of horizontal as being in the x direction. And I'm going to call this one here FAY because we think of up and down as the y direction. So I'm going to label those. This is FAX. And this one is going to be F-A-Y. So what I can do now is I can sort of think of, instead of there being 3 forces in this situation, I can sort of think there are 4 forces in this situation. What I've done is I've pretended that this force here, nope, oh, it's not going to let me do that. Okay. What I can sort of do is I can pretend that this force, right, nope, it's not going to let me choose that, is it? Okay, I'll erase it later. It's pretending that this force here doesn't exist, and I have broken it up into this one and this one. All right. So B now is asking to determine the weight of the cart. All it's asking for is what is this value of Fg. All right, we know how to do that. We know that Fg is mass times gravity. Gravity near Earth's surface is 9.8, and we have the mass of 15 over here. So we can very easily calculate that. We'll put it in our numbers. Our mass is 15, and gravity, is 9.8. And we'll be able to get a value here. And we're going to get 147 newtons. Okay. Excuse me. So that's B, determine the weight of the cart. C, determine how much force I push down on the cart. All right. So really, it is just asking me how much am I pushing straight down? How much is this component of the applied force that I am doing? What is Fay? Well, hopefully what you can recognize now is that I have a right angle triangle here, so I can apply all of my trigonometry. The applied force is 150 newtons. That's what the question tells us right here. So this hypotenuse is 150 newtons. I have an angle of 30 degrees here, and I'm looking for this Fay. So in this case, I'm going to be using sine. This is the opposite side. I have the hypotenuse, I have the angle. I should be able to figure that out. Alright, so we have sine of the angle is opposite over hypotenuse. We will place in our values. The hypotenuse is 150, and our angle is 30 degrees. Okay, so to rearrange, we're going to multiply both sides by 50. Sorry, multiply both sides by 150, and what we will get, and I'll rewrite all of this now, is that the opposite side, or in this case, our Fay is equal to, is equal to the sine of 30 multiplied by 150. And when we multiply that through, we should get 75. So, we got 75 newtons. Okay, so that's C, determine how much force I push down on the cart. Alright, so now when I'm looking at D, determine the normal force on the cart. Well, what I have to remember here is that this cart, or car, is not going to be accelerating up or down. It's not going to be starting to lift off of the ground. It's not going to start digging itself into the ground. So that means that all of the up and down forces have to cancel. They have to balance. Well, I happen to have two forces that go down. Fg, Fay. Both of them are pointing down. So something has to balance off both of those. I have Fn pointing up. So really, Fn needs to be the same value as Fay, me pushing down, and the weight, Fg, together. This value is 147. This value is 75. So really what I've got now is I have a new equation that I am really considering. Oop, that's not what I want, sorry. And let me just... Hold on, where did it go? Okay, I will try that again. We'll go like this. Yeah, let's go up here. Alright, so the new equation that I've got... Oh, come on. Nope. Does not like me doing this. There we go. Is that I have the normal force needs to be equal to, in this case, oh, come on, Fg plus Fay. There we go. And this equation I kind of have to develop on my own. I have to figure that out. I have to figure out that this plus this has to equal that. Now, technically, these are down and this is up, so it's as if, you know, we could call these ones negative and this one positive. But really, if I happen to have this over to the other side, it'd be a negative. And we said that these three added together have to cancel each other out. They have to equal 0. So really, I've built that positive negative in already. So I could have also written this that 0 equals Fg plus Fay minus Fn. I could do that as well. This to me makes a little bit more sense. I know that this force has to equal this one and this one together. Okay, and so now we can put in our values. And we know that Fg was 147 and Fay was 75. And so we get 222 newtons. There we go. So that'll be D, determine the normal force on the cart. Now E, determine the acceleration of the cart. Alright, well in order for us to do that, we do need to know what the net force is. I have the mass, I need the net force, and I can use F net equals ma. So that means that I have to combine all of these forces together. Well, in some ways, I've already made some of that work easy for me. I've already recognized that Fg, Fn, and Fay all cancel each other out. So I can pretty much ignore them. I can pretty much say that they do not exist. And Fay, I kind of broke up into Fax and Fa, I broke up into Fax and Fay, so it doesn't exist either. And, oh, guess I have to redraw my Fax. So all I'm left with was this horizontal force. That's it. Everything else canceled each other out. So if I can determine what this value is, right here, then I'll happen to know what the net force is, because the net force is the combination of all the forces. A whole bunch of other ones already canceled, so all I'm left with is this right here. So I'm going to show you a bit of a shortcut that we can do to try to put two steps into one. Alright, so here I've got my F net equals ma equation, and I did say that F net is all the forces combined. This one here is really F1 plus F2 plus F3 plus F4, so on and so forth. But all I'm left with is just FAX. So what I'm going to do is I'm going to replace this with FAX. I'm just going to say that F net is FAX, and I'm just going to change that. Alright, well, I need this value, mass I've got, to get the acceleration. So how do I get this value? Well, I can do a similar kind of thing that I did for Fn. We used sine of 30, I'm going to use the cos of 30. So we can see already that over here, I had taken the sine of 30 equals opposite over 150. While using the cos, it'll be the same thing. It'll be cos 30 equals adjacent over 150, and then you'll notice that I multiplied 150 to both sides. So really I'm going to have something that looks exactly the same as this for FAX, except this is now cos. So I'm going to replace that here. Alright, so we're going to get cos 30 times 150. Oh, and I'm going off of the page here, so let me move that over. There we go. And I can already put in the mass of 15. There we go. Alright, so if I take 150 and multiply it by the cos of 30, I get, when I round, 130. So we can put that in. So this side will be 130. And we have 15a over here. And then next, of course, we will need to divide both sides by 15. And so what we're going to get is that a is going to equal 130 divided by 15, and when we punch that into our calculator we get 8.67 repeating for our acceleration. 8.67, and we have meters per second squared. There we go. So I hope this was helpful. We have our answers, numerical answers for B, the weight of the car, is right here. Determine how much force I push down on the cart, that is right here, 75 newtons. Determine the normal force on the cart, that's right here, 222. And determine the acceleration of 8.67 meters per second squared right here. Hope you guys are doing well. Talk to you soon.